Again to the DS Incubator. Today we are talking about relational data. This is chapter 2 on this topic. Last time we talked about how to work with relational data using dplyr in a what today could be perceived as a more manual way of doing things. And today we're going to be talking about a package that is dedicated to the idea of working with relational data in R. It is the DM package. So this is the repository that hosts this meetup, 2 Degrees Investing ds.database, and let's go to the folder number 2 that hosts the notes for today. The DM package is a tool that it has a lot of functionality, but today I'm going to be focusing on the idea that it makes it easy to create data models, visualize them, check some of the properties that you want them to have, and to use data sets in general, to use complex data sets in general, to make it easy to work with many data sets or data sets that are large when you want to do things with them or share them. One key thing, I believe, is how easy it is to integrate with dplyr, either because you can use dplyr functions directly or because it has some functions itself that are very similar to dplyr functions, making it easy to reuse your knowledge if you already are used to working with dplyr. So because we're going to be talking about these two packages, we need to attach them first for the demo. So I'm going to do library DM for data model and library dplyr. The data sets that we're going to be using are tiny. We created them or we showed them last time. It is a data set composed of 2 tables. One table is called companies, and it has information about different companies. There is a total of 2 companies in this table. Company 1 and company 2 are the IDs of those companies, and then here in information we have a little bit of information what they sell or what services they provide. Then the categories data set is related to the first one, but by that column called company's ID. And this is the whole idea about relational data sets, where the data is spread across multiple tables, but those tables hold relationships that are linked through specific columns. We talked a little bit about that in the previous meetup, and today we're going to touch on that a bit more briefly. One thing I wanted to note here is that there is one row, this one here that I'm highlighting, that contains information about a company that exists in only one of the 2 data sets. And that is an issue that we're going to be exploring with the DM package and addressing it as well. So to begin with something familiar, a data model is the object that defines the DM package, and it is very similar to a list. So for example, if you create, in the same way that you create a list with the function list, you create a data model with the function DM. So let's create an object called DM. Actually, let me make this a little bit more prominent here, maybe a little bigger too. And I'm going to be using the equal sign for assignments that I usually do like this, but for a keyboard thing, I'm going to be using the equal sign. So the DM object here is just the variable name, an arbitrary name that I came up with, but I'm creating that data model object with the function DM from the DM package. And here, because I already have the data sets in the form of data frames, I'm going to just pass the names as variable names directly to the DM function. So one is I think it's misspelled. Let's do the whole thing again. Let's start with companies first, and then categories. So this is my DM object. And when you print a DM object, it's kind of boring in a very nice way. It doesn't produce a lot of output. It doesn't take any time to print. It's simply metadata about the data that this data model contains. So we have here the names of the tables, how many columns there are, and this information about what are the keys, or basically the columns that link the two data sets, the primary key and the foreign key so far are undefined. That's why it says primary key 0, foreign key 0. So you can use, in the most basic way, a data model as you would use a list. With the $sign syntax, you can simply give the name of one of those elements of that special list, for example, the company's data set. Wow, sorry, it looks like there's some alarm here, but I don't see any issue. Let me take a moment. Oh, stop. So apparently it's no drama here. So yes, you can, as a list, you can just call the DM object with the $sign syntax and the name of a table, and you would get the output as you would expect in a list. Or if you prefer, you could also use the square bracket syntax. Let's do that for categories. And the same happens, right? So up to that, categories, if I know how to spell that. There you go. Nothing surprising so far. The interesting thing starts when you define those keys. When you say, okay, take the DM object and add. So pretty much all the functions, except for a few, start with a DM prefix, which is nice because then it's easy to find functions like this one, for example, add primary key, pk. And you say, well, to which table you want to add a primary key, and then you say, well, for example, for companies, and which is the column that you want to be the primary key. Okay, yeah, in this case, it's gonna be companies ID, and if I print that object now, you already see how I'm adding that primary key that before was unset, and you could do the same thing with the foreign key, so add the foreign key. And now what we want to do is, so we add the foreign key to another table. So in this case, it is categories. And the same column in that other, or the column with the same name in that other data set, companies ID, here is a foreign key. Actually, I'm gonna make this a little more to the left, because I'm using more of that space, and maybe a tiny little bit smaller. So that is a foreign key that points from categories to the companies table, right? So it links these two tables together. So if I print that data model again, I get a little bit more of the metadata. So I already defined these two things. So because this is useful in itself, I'm gonna now create a variable called dm2. And let's start doing something fun. So the very first thing you can do, super easy, is to create a visualization of that data model, so we can see the relationship between the different tables. So the function that does that is dmDraw. So here is, actually you have it here also in the notes, but in the notes actually for some reason it kind of gets off of the squares. So you see the two tables, and you see an arrow pointing from the table that contains the foreign key pointing to the table that has the primary key. The primary key is highlighted in this case, underlined, sorry. And that's how you interpret this graph. You can imagine this being a lot more complex. You could have many tables, and there could be many columns in each table, but this graph focuses specifically on those that relate the tables to each other. So you reduce the complexity to something that you can understand more easily. So that's something pretty cool that you can do with very little effort. Once you define those keys, just with the function dmDraw, you see that little visualization that adds a lot of understanding. But another thing that is super easy to do here, and I'm going to show how it's not so easy to do by hand, is to check for the constraints that databases usually enforce. So you do that with the examine constraints. So that's a very simple call to just one function that checks for at least three things that I'm going to unpack in a moment. The first thing I want to show is that here there is a note or a message that says unsatisfied constraints. And the way you interpret that is as follows. So as I showed before, this row here that exists in the table that has a foreign key pointing to another table, it happens that one of the constraints that database enforce is that every single value in a foreign key should point to a value that actually does exist in the other table that holds the primary key. And this is not the case here, so that constraint is not satisfied. I think one of the examples later shows the result of that unmet constraint, which is basically a missing value when you join those two tables. So that was fairly inexpensive to compute, at least in terms of the cost of typing the code. I have done some examples with more real data, and it does take quite a bit of time. So it may not be inexpensive in terms of computation time, but it's kind of easy to type. For comparison, if you want to do the same thing on dplyr, the code that you will be typing is something similar to what we covered in the last meetup. So you would take the data, the table. So in this case, I'm using the data model as a list. So I get the company's data set, and what I'm doing here is just counting the number of times that I get different values of company's ID, because one of the constraints of a proper database is that every primary key value should be unique. And this output of 0 rows shows that it is indeed met. So that constraint is met. So the table that contains a table where I define a primary key has no duplicates. That's great. This other thing is also great too. This second constraint is the idea that every value in a table where you define every value of a primary key in a table that you define should not be missing. So here I'm checking if there is any row that has a missing value of that primary key in the table companies, and the answer is no, there is none, meaning that it meets the expectation. But then this third piece of code, what it does, the function anti-join is trying to find if any of the values in categories is not matched by a value in companies, and indeed there is one, which is that row that we highlighted before. So this is simply to show that to test for the constraints by hand is very expensive, very costly. You have to write a lot of code, and this is a very small data set. So for bigger things, bigger data sets, it's a pain. So you have to. There is a lot of value in this approach. Another great thing of the data model is that it allows you to, for example, flatten, so create a spreadsheet type of table out of multiple tables in a relatively easy way as well. So this is the idea. So here in this package is called flatten. So because we have only 2 tables in this data set, it's fairly simple. So basically what we are saying is, okay, start at the table categories and flatten every table that table points to. So in this case, let me go back to the figure, because we have only 2 tables. So we start at categories and we follow the arrow. So we get every column that comes from categories and then every column that comes from companies. So that would be the entire data set in a spreadsheet, in this kind of flat spreadsheet form. If there were more data sets, so if categories was pointing to not only companies but to some other table or tables, then all of those could be flattened, and you could get the columns that come from all of them, which is very nice. That you get that with just one call, as opposed to having to explicitly say, okay, merge this table and then another table and then another table, and each time explain by which column you want them to join, which is kind of the manual approach I have to do with dplyr. So sorry, I'm scrolling down as I speak. So the 2 things that you have to define here for this to work is the table from which you start flattening your data set, and if you want, you say recursive true, so that every table that you continue with the arrows as far in the graph that I show, as far to the right as you could go, pretty much. So joining every single table that is pointed to. And if you say recursive false, which is the default, then only the first one that is reached by one arrow, but not one table that then points another table and then another table and so on and so forth. Also, as I mentioned before, one feature that I believe is very important is that the data models are very well integrated with the dplyr package in two ways, either because you can use dplyr itself or because you can use functions that feel as if they were dplyr functions. So let me show you that, because that's a little bit more terse. Let's unpack that a little bit with a demo. So I'm gonna move here to our studio. So I have this dm2 object. Let's refresh our minds what it was. So one thing you can do if you want to use dplyr directly, you need to first say, because dplyr works with just one table, right? And the data model has as many tables as it has. So in this case, it has two. So we have to specify somehow which table we want to kind of zoom in so that we can then use dplyr function. So that the feature that does that is dm zoom to. So we zoom to, in this case, for example, the categories table, which was the one that had that problematic row. So let's try as an example to use this idea to remove that row that was a problem. So say that we looked at the data, we identified that is the row where company's ID is number 3, so we want to exclude that one. And because we know how to use dplyr, we know that filter is the function that does that. So we say, well, filter companies company IDs where this is not equal to 3. So that's the syntax. And that's the trick. So if you print that, where you see that you're actually working with just one table as you would normally do with dplyr, which makes sense, right? Because dplyr knows about one single table at the time. But then if you want to make that part of the entire data model, then you basically what you do is you update the zoomed model, right? So by doing that, you first filter that one table where the values were not 3, and then you updated the entire model. So if we were about to do that, then we would probably store that in dm number 3, for example, and that would be the trick. So the same thing or similar. So this piece of code what demonstrates is that you can use dplyr right away. So if you already know how to use dplyr, you simply zoom into a table, then use dplyr, and then you may want to kind of update that data model, and you are fully reusing your knowledge about dplyr. But then another approach is to use functions that feel like they are dplyr, but they are not. They are functions from the dm package. So if I take that dm object number 2, there is this dm filter. So instead of filter, it's just dm filter, which makes a lot of sense. And here you have to say, so the syntax is a bit more compact. But again, we need to explain in this new approach, we need to explain which table we want to work with. So before we use dm zoom to, and now we explicitly say, as if it was the name of a variable, we say categories, which is the name of the table we want to work to. And then after the equal, what we do is simply, we get everything that we could have typed into a filter call, including the parentheses, which is kind of weird, but it is what it is. And then you just paste that there, and that's the trick. So that is a more compact way to do the same. So the same dm3, we could create in that way. And once you have that, just to prove to you that we have excluded that row, what I'm going to do is dm3 and check those constraints. So dm examine the constraints, and that should say now that all constraints are satisfied because the problematic row is gone. This is only the very, very, very tip of the iceberg here. The package has a lot of really cool features that get a lot more into that give you functionality that it will feel super familiar with for people that have been working with SQL or databases on a cloud service or SQLite databases stored in memory. I'm planning to touch in some of those ideas next time. But for now, I wanted to point to the website of this package. In particular, to note where you can learn yourself if you want to take a deep look at all of this, because we want. So this is all pretty much what I wanted to talk about, the bigger features of the package, and then next time I'm thinking of talking a little bit about remote databases and just showing a little bit of TM there, but not much. So the first page has been very much inspiration for this meetup. This second page that says get started as well. So in those two places, you will find more or less what you have just seen. Then the references in every package website, you will have all the functions, but I highlight that the tutorials and technical articles of the website are very complete, maybe even too much, and you might feel a little bit overwhelmed, but they are there, so see that, know that they are there, and you can also learn about data models in general. The first tutorial is mostly theoretical. It's one that I have found very useful to refresh some contents and to learn a few things that I didn't know about. So if you're behind, if you're after some theory, you may want to come here. If you're after implementation, you may want to read other articles. But all in all, know that there's a lot of content here that could help you, and as it is helping me, walk along that path of learning to work with relational data models in R. So that's all I have prepared for today. We have here Miria, who has worked with relational data, maybe not with this package, but relational data in general. So I'm going to ask if there is any question or comment, Miria, that you'd like to share.
Maybe just a quick specific question. So does the data models package also support specific check constraints? For example, could I define that my column may not have values outside 1 and 0 or something like that?
Yes, a good point. I was thinking in terms of conversation we have had, if you can define those constraints beyond the basic constraints on primary keys. The answer is I don't know, but I will find out, because that's kind of my homework for the next week or so. It won't be captured here, but if I learn it, I may say it next time I'm here on this meetup.
Amazing. And by the same token, maybe if it can check for type, and if it can handle unique and composite unique constraints.
Perfect. All right, thanks a lot. I use that then as a guide to my learnings. In my first pass to these functions, I don't recall having seen that, but I'll find out. All right, so there is some checks here. Some constraints, check key, check set equality, set. There is something promising here, but also maybe that could lead me to learning and talking about the point blank or some other packages that may complement this. It could be nice, I think, to find some examples of this package in the wild and see how, as you say, Miria, like the fuller checks have been implemented. How much of those checks come from the DM package directly, and how much comes from elsewhere. All right, thanks a lot, Mia, again for being here, but also for inspiring this series, and everyone else who is around. Thank you, and see you next time.
Thank you. Bye-bye.
Ciao, ciao.